Welcome back. In this video, we are going to solve problem 12-36 that is taken from chapter number 12, Deflection of Beams and Shaft. And the book name is Mechanics of Material by R.C. Hibbeler. So the statement of the problem is determine the equation of elastic curve, the slope at A and deflection of B of the simply supported beam. EI is constant. So you can see this is the simply supported beam where at point B there is a moment m naught and at point C there is also a moment that is m naught. So due to this loading the beam will bend like this. So we have to find the equation of elastic curve, clear, which is the equation of deflection, the slope at point A, this is the slope theta A, and deflection at point B. So this will be the deflection at point B, which is VB. So let's start with the solution. So first step is that if you remove this pin support, so there will be a reaction force. Let this reaction force is RA, and if you remove this roller support at point D, so you will be having a reaction force which is RD. So we will find this RA and RD by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point A is equal to 0 and taking the counterclockwise movement as positive. So about point A, one movement is this m naught which is clockwise, so it will be negative. The other movement is this m naught which is counterclockwise and that will be positive, and the third movement will be RD into this length which is L, and this will be again counterclockwise, so it will be positive. But the sum of all moment about point A will be equal to 0. So I will write minus m naught plus m naught plus Rd into L is equal to 0. So from here you will get this Rd into L is equal to 0. So it means that reaction at point D is also equal to 0. So this is Rd. Now we'll find Ra by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So we have two forces, that is Ra, that is upward, plus Rd which is equal to 0 is equal to 0. So from here you will get Ra is also equal to 0. Now you can see that this is 0 and this Ra is 0. So what we will do is that we are going to find out equation of elastic curve that can be found by using this formula EI into d square V over dx square is equal to moment. So what we will do is that we will find moment by using singularity function, and you can see this table. From here you can see that we have the moments only. So what we will do is that if you go to the row number 3, sorry, row number 1, that is about moment. If this moment is applied at a distance of A and x start from this place, there, so x start from this place, and you can see the moment equation will be first moment is this one, and this is at a distance of L by 3. So you can see this moment is clockwise and this is also clockwise. So our equation will be equal to plus m naught into x minus a. So a will be replaced by L by 3. So x minus L by 3 power 0. The second movement is counterclockwise, so it will be minus m naught into x minus a. Remember, this is not parenthesis, this is Macaulay bracket. So, okay, m naught into x minus a. So, x minus, now here for this m naught, L will be equal to 2L by 3, because L by 3 plus L by 3 will give you 2L by 3. So A will be replaced with 2L by 3 and power will be equal to 0 because this is given in this formula. So this is your moment equation. If you simplify it, you will get the same this equation. So put this equation, let this is equation number A. So put the value of m in equation A. So you will get EI into d square V over dx square will be equal to m naught into x minus L by 3 power 0 minus m naught into x minus 2L by 3 power 0. So what we will do is that we will integrate this. So integrate it, you will get e into I d square v over dx square will be equal to m naught into x minus L by 3 it power 1 divided by 1 minus m naught into x minus 2L by 3 power 1 divided by 1 plus c1. That this is your equation number 1. Now what we will do is that you have to again integrate equation 1, again integrate equation 1. So you will get e into I into v, which is deflection, is equal to m naught into x minus L by 3 power 2 divided by 2 minus m naught into x minus 2L by 3 power 2 divided by 2 plus c1 into x plus c2, and this is equation number 2. Now c1 and c2 are unknown constant of integration and they can be found by using boundary condition. So boundary condition. So what are the boundary conditions? So first boundary condition is that at x is equal to L by 2, we have slope which is dv over dx will be equal to 0. So let me show, due to this loading the beam will bend like this, clear? So you can see that here at this, at x is equal, total length is L, so here at x is equal to L by 2, you can see if you take the tangent to this curve, so the slope will be equal to 0. So dv over dx will be equal to 0. So what we will do is that you have to put it in equation number 1. Put in equation 1. Now what is equation number 1? This is the equation of number 1. Okay, so here you have taken integration, so it will be dv over dx. Okay, so when you put dv over dx, this term is equal to 0, so you will get e into I into 0 is equal to m naught into L by 2 minus L by 3 power 1 minus m naught into x minus x will be replaced with L by 2, so L by 2 minus 2L by 3 power 1 plus c1. Okay, so this is 0. This term will be equal to m naught into L by 2 minus L by 3 minus m naught into, this term will be 0 because you can see that L by 2 is less than from L by 2 L by 3, so this term will be negative, and anything inside the Macaulay bracket that is negative will be considered as 0. So I will write m naught into 0 plus c1. So from here you will get c1 will be equal to minus m naught into, if you take LCM, so it will be 6, so 3L minus 2L, and you will get C1 will be equal to minus m naught L over 6. So this is the value of C1. Now we will find C2 by using another boundary condition, and this boundary condition is that at x is equal to 0 we have at x is equal to 0 we have deflection is equal to 0. So let me show you. Here you can see at x is equal to 0 deflection is equal to 0 because this is supported at point A. So we will put it in this equation number 2, because equation number 2 is about deflection. So here this term will become 0 and this term will be equal to m naught into 0 minus L by 3 power 2 minus m naught over 2 into 0 minus 2L by 3 power 2 plus C1x, which is m naught into L over 6 Sx plus C2. So this term will be equal to 0 because this will be negative. Anything inside the negative, inside the Macaulay's bracket that is negative will be considered as 0. Similarly, this term will be equal to 0. So we will left with 0 is equal to 0 minus 0 minus m naught L. Okay. Over 6 and x is also 0. So this will be 0 plus C2. So from here you will get C2 will be also equal to 0. So you have C1 and C2 value. So what we have been asked, we have been asked to find the equation of elastic curve. So what we will do is that put C1 and C2 in equation number 2. So when you put it, you will get E into I into V is equal to m naught over by 2 into x minus L by 3 power 2 minus m naught by 2 into x minus 2L by 3 square. C1 is minus m naught L by 6 into x and C2 is 0. So divide EI on both sides. So what we will get is V is equal to 1 over EI into the same thing, which is m naught by 2 into x minus L by 3 whole square minus m naught by 2 into x minus 2L by 3 whole square minus m naught L x by 6. Now what if you take m naught over 6 common? So m naught over 6 is common and EI is also there. So you will get 3 into x minus L by 3 whole square minus 3 into x minus 2L over 3 whole square minus L into x. So if you multiply m naught over 6i, you will get the same equation that is mentioned above. And this is the required equation of elastic curve. Is required equation of elastic curve, or this is the equation of deflection. So if you put the value of x, so you will get the deflection at that point over the length of the beam. And this is the answer of our first part. Now we will move towards second part, and in second part we have been asked to find the slope at point A. So what we will do is that put the value of C1 in equation number 1, put C1 in equation number 1. So this is equation number 1. EI into dV over d, EI into dV over dx into EI. So I will, okay, EI into dV over dx is equal to m naught into Lx, m naught into L minus x minus L by 3 power 1 minus m naught into x minus L 2L by 3 power 1 plus C1. So C1 is minus m naught L over 6. So divide EI on both sides. So we will get dV over dx is equal to 1 over EI into m naught minus x minus L by 3 m naught into minus m naught into x minus 2L by 3 minus m naught into L divided by 6. And if you take m naught over 6 as common, so this will be equal to m naught by 6. So you will have only this term, x minus L by 3, x minus 2L by 3, and this will be equal to minus L only. Okay. So this is the equation of slope. I will copy it and we will move toward the second page. Copy it and I will paste it over here. So you will get this dv over dx is equal to slope. Okay, dv over dx is equal to slope, and that is equal to m naught over 6ei into x minus 6 minus xl by 3 minus 6 into x minus 2l by 3 minus l. Here is 6. Kindly make a correction here. When you take 6, so here you will be having 6, because when you multiply it you will get the same equation. Okay. So this is the slope equation. Now we have to find the slope at point A. So here at x is equal to 0, we have slope will be equal to theta A. So at x is equal to 0, we have slope is equal to theta A, or dv over dx at x is equal to 0. So put the value of x in this equation B. Put in equation B. So what we will get is theta A will be equal to m naught over 6 ei into 6 minus x is 0 minus L by 3 minus 6 into 0 minus 2L by 3 minus L. So this value inside the Macaulay bracket will be negative, and anything inside Macaulay bracket that is negative will be considered as 0. So this will be 0 and this will be also 0. So we will left with m naught over 6 ei into minus L, and this theta A will be equal to minus m naught L over 6 ei. So this is the value of slope at point A, and that is the answer of our second part. Now we will move toward third part, and in third part we have been asked to find the deflection at point B. Let me show you their deflection at point B, that is x is equal to L by 3. So what we will do is that we will first copy the equation of deflection. This is the equation of deflection or equation of elastic curve. Let me copy it and we will move toward second page. Here we will paste it. So this is equation of, so VB deflection at x is equal to L by 3. Okay. So at x is equal to L by 3. So put it in this, put x is equal to L by 3 in above equation of elastic curve. You will get deflection which is at point B will be equal to m naught over 6 ei into 3 minus 3 into L by 3 minus L by 3 power 2 minus 3 into L by 3 minus 2L by 3 whole square minus L by 3 L minus L into L by 3. So it will be equal to m naught over 6 ei, that is deflection of beam, into this term will be 0. So 3 into 0 minus 3 into L by 3 is less than 2L by 3. So this whole term will be negative. So anything inside the negative that is negative inside Macaulay will be 0. So this will be 0, and we will left with L square over 3. And when you solve it further, you will get deflection at point B is equal to minus m naught L square over 18 EI. Or you can say deflection at point B is m naught L square 18 EI, and that is downward. Negative sign means that deflection is downward. So if you know the value of m naught, total length of the beam, modulus of elasticity, and I, so you can find the deflection at point B will be this one. Now we will move toward problem 12-37, and that is the same question as 12-36, only the maximum deflection of simply supported beam is different. EI is constant. So in this question, we have to find equation of elastic curve and maximum deflection. So equation of elastic curve is already, we have find out in problem 12-36, clear? So that we have explained earlier, and this was the equation of elastic curve. Now we find the maximum deflection. So you can see that maximum deflection, due to the loading, the beam was bent like this. So maximum deflection will be this one at the mid of the beam. So at x is equal to L by 2, we have maximum deflection Vmax. So put x is equal to L by 2, where slope is dv over dx is equal to 0, and we have maximum deflection. So put it in this equation, so you will get Vmax is equal to m naught by 6 EI, and x will be 3 into x will be replaced by L by 2 minus L by 3 power square minus 3 into L by 2 minus 2L by 3 square minus L into L by 2. Okay, so this will become Vmax will become equal to m naught over 6 EI into 3 multiplied by this will, if we take the LCM, so this will be equal to 6. So 3L minus 2L square minus this term will be equal to 0 because L by 2 is less than 2L by 3, so it will be negative term, so this term will be equal to 0, minus 3 into 0 minus L square over 2. Okay, so we will get Vmax will be equal to m naught over 6 EI into 3 times L by 6 whole square minus L square over 2. So you will get m naught over 6 EI into 3L square over 36 minus L square by 2. So that will be equal to m naught over 6 EI, and if you take the LCM, that will be 72. So 72 divided by 36 is 2, and 2 into 3 is 6. So 6L square minus 72 is divided by 2 is 36. So 36L square. So you will get Vmax is equal to m naught over 6 EI into minus 30L square over 72. Okay, so 6 ones are 6, 6 5s are 30, so it will be minus 5 m naught L square over 72 EI. So Vmax is equal to minus 5 m naught L square over 72 EI, or Vmax is equal to 5 m naught L square over 72 EI, and this will be, the deflection will be downward. And this is answer of our question number 12-37. And that was all about both this problem 12-36 and 37. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching and supporting me.